In this movie, I'll show you how to decide where your anchor points and control handles should be to accurately trace a shape. So if you have access to my exercise file, I've created a kind of cheat. There's this layer here called points and handles, and it's a kind of template for where the anchor points and control handles should be that I created by taking a screenshot and colorizing it red. And so if you go ahead and match the template by dragging the square anchor points onto the square points in the template and dragging the circular control handles so they match the locations of the control handles in the template, then you'll end up reproducing my path outline and you'll achieve the desired results where this droplet is concerned. And notice as you work your way through things, obviously we're modifying the position of the segments and their curvature as well. So you have to always bear in mind that the segment has to travel through the anchor point, but it never actually touches the control handle. The control handle just pulls at it. It has this kind of magnetic attraction, and it repels the segment as well as you start getting closer to it. Then once you pass to the other side of the segment, you stretch it in this new direction. If you ever get this number here where you twist the segment all the way around, the solution is very simple. Just drag the control handles all the way back to their previous position. There is no reason, incidentally, to put a control handle directly on a path outline. That doesn't serve you any purpose. In fact, it defeats the purpose of the control handle because it's going to flatten out that portion of the segment. And if you wanted to do that, you wouldn't need a control handle at all. All right, so I'm going to go ahead and drag this guy up to this location right there, and then I'll drag this control handle in. As you're dragging a control handle that's associated with a smooth point, always bear in mind that you're going to change the angle of the opposite control handle as well, but you're not going to change its position. In other words, it's going to remain the same distance away from the anchor point that it was before. So we're ultimately departing from the previous symmetry that we had when we were looking at that perfect ellipse. Now, Photoshop displays the path outline by inverting the composite image. So if you're working along with me, anytime you manage to exactly match the template, your control handles and anchor points are going to turn cyan because cyan is the complement to red. Also, something to note is that this template is designed to look best at the 50% zoom ratio. If you zoom in any farther, then it's going to look a little bit jagged, but it should still serve its purpose. All right, I've now managed to match every single one of these points, so I can go ahead and hide my points and handles layer. Now, given that we were working from a cheat layer here, it's no trick getting the proper results. However, you may wonder why in the world I chose these locations for my anchor points and my control handles. For example, why is this guy, instead of being centered at the top of the droplet, why is he listing over to the right? And why is this anchor point over on the left-hand side located so close to this hairpin curve? Well, when you're working with corner points, it's pretty easy to decide where those points belong because you're just trying to match the corners of the image element that you want to mask. But when you're working with smooth points, you're always creating continuous arcs. So it's a little trickier trying to decide where those points need to be. I subscribe to a kind of driving analogy. So imagine that you're driving along this path outline, and for the sake of demonstration, imagine you're driving in a counterclockwise direction. So as you drive along this segment here, the road is pretty steady. That is, it's curving to a more or less constant degree. So you hold the steering wheel at a constant angle. However, right at this location here, as you swoop into the hairpin curve, you need to change the angle of the steering wheel. Specifically, you need to angle it more. Hopefully, you'd slow down as well. And that's exactly where you want to put the anchor points, at those locations where you're changing the angle of the steering wheel. So right here, we're steering harder, and as a result, the anchor point belongs at that location. Doesn't have to be there, by the way. It just makes for an easier experience and a smoother experience as well when you're tracing continuously curving image elements. Where this anchor point is concerned, imagine that you're driving in a clockwise manner, because it really doesn't matter which direction you're driving. We're just looking, once again, for points at which you're going to change the angle of your steering wheel. And in this case, you'd want to ratchet up the steering right at this position here. So while that explains the side points, what about the top and bottom points? Well, the bottom anchor point is located pretty much right here at the center of the base of the droplet. And this does happen to be pretty much the bottommost point to which this curve dips. Not so for the top point, however. It's over to the right of the apex of the curve, And all I have to say for that one is in playing around and experimenting with the position of the anchor point, this worked out best. So sometimes you just have to rely on experience in order to get the job done. And the only way to build up that experience, of course, is to work with the pen tool on a routine basis. Now let's talk about the control handles here. There's two rules where control handles are concerned. Notice that we have two control handles for this curving segment. One as the segment exits this top anchor point, and another one as it enters the left-hand point. And it really doesn't matter which direction the segment is traveling, but we essentially have an exit control handle and an entrance control handle. And that's the way we want it. You either want two control handles for a curving segment, or you want zero control handles in the case of a straight segment. If you have just one control handle for a segment, as often as not, it's going to appear lopsided. The other rule is that you want the control handles together to add up to about 2/3 of the length of the segment. That's going to give you the smoothest result. They don't have to be the same length. You can see that the left-hand handle is shorter than the top one, but together they should add up to about 2/3. Now that is a rule of thumb, and you will find yourself violating it sometimes. Notice if I click on this bottom left segment that the control handles are different lengths, which is fine. They don't really add up to 2/3 of the length of the segment, because if they did, I wouldn't be accurately tracing the droplet. So I'll go ahead and press Control-Z or Command-Z on the Mac. However, they do add up to more than 50% of the length of the segment, which is generally essential to get the job done. All right, now let's go ahead and convert this path outline to a vector mask, and you can do that from the Layers panel by dropping down to the Add Layer Mask icon, and just as we did in the Paths panel, you press the Control key or the Command key on the Mac and click on it, and that converts that path to a vector mask. Now I'll click on the vector mask to make it active, click again in order to hide it, and I'll go ahead and zoom in as well. And here we have what was originally a perfect ellipse, tracing a custom organic image element here inside Photoshop.